Hello, how's it going, grade nines? We are moving on today to matching equations and graphs together. So we spent a lot of time looking at different equations, making them based on a relationship from our table, graphing those relations as well. I've given you a ton of practice on that. Now we have to start understanding the opposite, where if I just give you the equation, can you tell me what the graph looks like? And that's essentially what, it's exactly what we're going to look into here. Okay, so this is called matching equations and graphs. And we're just going to work through one example, and then we'll see how we feel about working with this. All right, so the example that I have for you here is I've got three graphs that I've drawn out, and there are three equations. Those equations are listed right here in a line. So m is equal to 2d plus 3, m is equal to 4d, and m is equal to d plus 5. Each of these graphs that I've drawn at the top match up to one of these equations. All right, so there are, I'm sure there's a number of ways to solve a problem like this one. There's one way that I like to solve it. I'm going to show you that second. The first thing that you can do is try to apply logic, just based on what you know already. If I had given you a graph, could you make an equation, for example? So let's look at a few of these. I'm going to start with the first graph. That's the first one that I see, and let's see what kind of relationship that we have. My axis on the bottom here, my horizontal axis, that is represented by letter D. And my vertical axis, that's represented by the letter M. Now my points go from 0 to 1, 1 to 2. So on the bottom, on the D axis, it's going up by 1. And on my M axis, going up and down, it's going up by 4. 4, 8, 12, 16, so on and so forth. So when I move 1 to the right, 1 for D, my M value is 4. So every time I have 1D, I have 4 M's. If I move 2D over, I should have 8M. And that's true. It's essentially what we've got here. Which of these equations satisfies that relationship? Well, this first one over here, it's doubling D. And I did double. I went from 1 to 2. But then I added 3. And at no point in our logic did we add 3. So this one over here is out of the question. And you might have figured out the second one here is the solution. But if you didn't know, our third one here adds 5. We never added 5 to anything when we're looking at this relation over here. Let's double check on the second one though. M should be equal to 4 times D. So no matter what number I pick on the D axis, if I multiply that by 4, that's what I should get on the M axis. So if I went to 3, for example, 3 times 4 is 12. So I should be matched up with 12. 4 on the D axis, 4 times 4 is 16. So I should be at 16 on the M axis. So this one over here matches up with B. Okay, now that's a great example because it's straightforward. It's just one step. These other two, A and C, there's a couple of things going on. Especially with A, you're multiplying by 2 and you're adding by 3. On C, you're just adding by 5. We can still apply the same logic though to our other pictures. Along the D axis, it still goes up by 1s. Every time I increase D by 1, how much does M increase by? So for example, when D is equal to 1, that's right over here, M is, that's a tough one. It looks like it's just above 4. Maybe it's at 5. So what did I have to do to 1 to get it to 5? Did I add 5 to 1? No. Because 5 plus 1 would give me 6. Did I multiply 1 by 2 and then add 3? It's a little convoluted, but yeah, essentially that's what happened, right? 2 times 1 is 2, plus 3 is 5. So it looks like A matches up, but let's try that with another point. Let's look at 4, and 4 seems to match up at maybe 10 or 11. Well, let's try the same equation. 2 times 4 gives us 8. 8 plus 3 is 11. So that seems to work for this picture. I would commit to that. A really smart thing to do in math, though, is always double check your work. So maybe let's try that equation on this last situation. Does the same thing happen in the last situation? Well, if I start at 1, I'm at maybe 5, maybe 6. If I'm at 5, it's the exact same situation, so it works. Let's try 4. Let's see what's going on with 4. 4 is over here. It seems to be matching up at maybe 9 or 10-ish. It doesn't quite look at 11. So A does not match up with our third graph. So the last thing to do is, process of elimination. We could just say, yeah, this has to be C. But that's not necessarily true. We need to make sure that the math makes sense as well. So M is equal to D plus 5. If D is equal to 1, M must be 6, because 1 plus 5 is 6. And it looks like, yeah, that's about in the middle, in between 4 and 8, so that makes sense. Let's try the other extreme. D, if that's equal to 4, 4 plus 5 is 9. So 9 would be somewhere around here, and yeah, seems to match up. Okay, so let's clear the board. Now I want to show you a different example, something that I like to do.